So C is Adna, 7th grade. Mitran, 7th grade. You both in the same grade. So that's why you both are in the same class. This is for level 2 of maths. Okay? And when we say level 2 of math, we're talking about all the concepts that we are supposed to learn from 6th to 8th grade for maths. Okay? So, this is the first class where we have more than one kid. So, I call you guys kid, right? That's okay. So, we are not into two classes. We talked about exponents.
Okay.
Right? That's the first thing we did. What was the second concept that we learned? Ratios. Yeah? And percentages we were tending to start, but we did not start. Yeah? So before I go anywhere, let's go. Huh? Okay.
What school do you go to? Huh? Okay, where is that? After school?
Okay. Come back to the class. So next 50 minutes is mine. Full focus. Okay? So here are the things that we do. We'll make sure that we learn tables. Tables are very important because that help you do maths quickly. Now, so we'll quickly talk about that. We'll go through what we have learned in the previous classes so that Mitran is also on the same page. Okay? And then we'll learn some new concepts today. So honestly tell me, you know tables till which? So when I say tables, meaning 2 1 2 10 20. That's a table of 2. So likewise, you know tables till which number? Which, remember?
Who, me?
Yeah?
I only know up till 12.
12. Okay. How about you? Just be honest. That's okay. I mean, we'll 11. Okay. So 10 and 11 we don't have to memorize. It's very easy, right? Table of 10, if you see, it's 10 1 is 10, 10 2 is 20, right? 10 3 is 30. Don't have to remember, right? Somebody says 10 times 6, 60. Very easy. Now, same way, if you look at the table of 11, that's also very easy. 11 times 1, 11. 11 times 2, 22. 11 times 3, 33. So 11 times 9, 99. 11 times 10, 110. This is also fairly easy. Okay. You don't have to memorize the table of 1. No need. Yeah. So you start with 2, 2 to 9, 10 and 11 you don't have to because these are easy ones. Then you do from 12 till 20. This is our target. What I try to make sure is level 1, meaning kids from 3rd to 5th grade, they should know tables till 12. Okay. Level 2 should know at least table till 16. Level 3 should know table till 20. And when I say table till 20, what it means is if I say 17 5, it should be 85. That quick.
Are we gonna have to memorize 2-digit into 2-digit?
We don't have to memorize. We have to just first memorize the tables. That's the basic building block for math. Okay.
Okay.
And then we'll use different tricks for doing sums or math faster. Okay.
Okay.
Now, so let me check. If you say you know tables till 11 12, let me see
12
how.
to 12.
Okay. Yeah. So let me check. 9 7s are.
9 7 63.
Okay. 8 4s are.
32.
Okay. And again, if I'm asking questions, not to make anybody feel good or bad, I'm trying to find out opportunities where we have to spend time to make it quick. Okay. 9 9s are.
9 9s are 81.
Okay. 8 8s are. 64. So we'll work on that to make it quick. So now my you said you remember till 12. 12 6 are.
12 6 are 72.
Okay. 12 9s are.
Both nines are 108.
108. Okay. So if we say that we know tables, we'll make sure that it comes in less than a second. Okay. That if we get to that stage, then only we will claim that yes, we know tables. I'll help you get there. Okay. So there's a strategy for that. I want you guys to spend 5 minutes every day
Hmm.
for memorizing tables. Let's say I learned those tables almost 35 years ago
Mm-hmm.
when I was half your age, probably, yeah, in early school. And then at later point in time, I kept realizing that okay, I'm forgetting them. So I used to like write it down and just go through it like singing a song. 10 1 10, 10 2 12, 20, 10 3 30, 10 4 40, 10 5 50. I'll just sing it like a song and say it loud and clear so that it gets registered here. Okay. So my request to you guys. So let's say for Anna, 2 to 9. Okay. You have a week's time after tomorrow's class. Daily, just keep 5 minutes for yourself. Separate for this one, okay? Whenever you're getting bored doing something, just spending time with yourself, okay? Just pick up one table, okay? Let me see if I remember. 2, you will remember for sure. I don't have to worry about it. 2 8 is 16, right? 2 9 is 18. Yeah. So 2 and 3, I can give you in writing that 2 3 4 you will know by for sure. You'll probably start with 6. Check if you are comfortable with 6. Okay. Ask yourself, okay, 6 7 is 42. Okay, good. 6 8 is 48. Okay, 6 9 is 54. Fine, wonderful. You're through. So just check for yourself, okay? Not for me, not for anybody else. Check for yourself. Okay. 2 I'm clear, 3 I'm clear, 4 I'm clear, 5 I'm clear, 6 I'm clear, 7 I'm okay. 8 is where I have to put effort. To make sure that my response comes in less than a second. Clear? Do that exercise for yourself, okay? So in the next class, again I will keep asking you guys, and then we'll do tables together, okay? We'll do it like singing a song for 5 minutes. Initial 5 minutes of the class, we'll say, okay, let's do table of 14 today. Let's do table of 14 today. Come over. Come, one of you, come over. We'll sing this together. Come with me. I'm also practicing, okay? Are you okay? Anna? Fine? Yeah. We'll do it together, okay? I make sure that the kids feel very comfortable here, okay? We'll sing it together. Come here. So 14 1 is 14. You don't know 14 table, right? Table of 14?
No. And 13. Same with 13.
Okay, we are doing 4. Okay, let's do 13 today, okay?
Mm-hmm.
We are doing it together. 13 1 is 13.
31, 13.
You will sing it with me, okay? An elderly person can sing, you guys are kids, right? 13 1 is 13.
13
13 2 is 26. 13 3 is 39. 13 4 is 52. 13 5 is 65. 13 6 is 78. 13 7 is 91. 13 8 is 104. So say it loud, okay? That's okay. You have not memorized it before, so obviously you would not remember it. It's okay. So let's do it together, okay? So I don't want you to be in the video then. You can be there. I will sing. You guys will repeat with me with equal clarity, okay? Loud and clear, okay? I want to hear it. 13 1 is 13.
13 ones are 13.
13 2 is 36.
13 twos are 36.
13 3 is 39.
13 threes are 39.
13 4 is
13 fours are
52.
52.
52. Say it loud and clear. Okay. So, beta, when you guys will say it loud and clear, right? It will be helping you. It will be helping me also. 13 5 is 65.
13 6 are
78.
78.
13 7 is 91. 13 8 is 104. 13 9 is 117. 13 10 is 130. This is just 2 minute ritual we will do every class. Okay. Now, let's look at what all I and Arna discussed and see if Mithran knows about it. Okay, so I'll not ask you to disclose the secret. Let's see if Mithran knows about it. If I have to do 2 to the power 4 and 2 to the power 3, what will be the value?
2 to the power 9.
This is 3, okay?
Oh, 7.
Okay. And how did you do that?
Because I added the 4 and the 7.
Okay.
4 and the 3.
Yes. Right? Anna, you remember this one? We learned this. So the formula for this one is called x to the power a into x to the power b becomes x to the power a plus b.
Should we write this?
You can write it if you want to.
Okay.
So any number, x is a number here, to the power a into x to the power b becomes x to the power a plus b. So that is how it became 2 to the power 4 into 2 to the power 3 is 2 to the power 4 plus 3. This one you remember, right? Yeah?
We learned this in 7th grade.
That's okay. Doesn't matter. Math is something that you learn at any age.
Okay.
So once you learn it, if you are clear about the concept, it's done deal. Okay? Now, so now this time let me confirm if Adna, were you able to do the homework? No? Why?
Well, I did a little
Little bit? Okay. No, so that is more like a protocol that we'll follow. After every class, I'll give the homework to you guys. Try doing it. Take a printout of that from your parents' phone. Try doing that homework. It is not like I'm doing any policing here, but it is a chance for me to know that whatever I have taught you guys, are you able to do it by yourself? Okay? Using that concept. Okay? And if you're not able to do it, let me know so that I would figure out an alternate and easier way to explain that. Yeah? Okay. And if you guys want to get closer to the pool table, that if that helps you put your this thing and write, that's also okay for me. Okay. Now let's check. 5 to the power 15 into 5 to the power 8. Arna, what will be that?
24.
Hmm?
5 to the power
5 to the power?
24.
No. 15 plus 8. Is that 33 or 24?
23.
Yeah. So you were going the right approach actually, just that you rushed a little bit here. Okay. Now, next question. 10 to the power 8 divided by 10 to the power 3. Do you know this?
10 to the power 5?
Why?
Because I subtracted the 8 and the 3.
Yes. 8 minus 3. You remember this or not? We learned this. Okay. So what happens is, this is another formula. X to the power a divided by x to the power b is x to the power a minus b. Here x is 10, a is 8, b is 3. Yeah.
Okay.
So clear? Why we are using these formulas? We can also do it if somebody says 10 to the power 8 by 10 to the power 3. I will say, okay, 10 to the power 8 means 10 into 10 into 10 into 10 into 10 into 10, 3, 3, 6 into 10 into 10 divided by 10, 3 times 10. Yeah? And then this 10 kills this 10, this 10 kills this 10, this 10 kills this 10. Now I'm left with 10, 1, 2, 3, 4, 5. So 5 times 10, that becomes 10 to the power 5. Yeah? This is one way of doing it. This is the most conventional way of doing it. But the life gets more interesting if somebody says, find out 10 to the power 48 divided by 10 to the power 18. Do you really want to spend so much time writing it 48 times and then doing this, right? That is where
You can use a calculator to make it faster.
I don't use calculator.
Okay.
I don't want you guys to use calculator either. So that is where the formula helps, right? So this becomes 48 minus 18. So instead of writing it that many times, I can use this formula, x to the power a by x to the power b equals to x to the power a minus b. Here x is 10, right? A is 48, B is 18. I just applied that formula here, substituted the value, and I got the answer in 10 power 30. In very easy, simple way, without relying on calculator, without wasting so much effort writing it that many times. Yeah, so that's the advantage of this one. Okay, so Arna, you remember this one, right?
Yeah.
Okay, good. Now, this is another thing that we learned in the previous class with the exponents. How much is that? Arna would remember that. I'm just checking with Mitra.
I forgot.
You forgot? Okay. Arna, do you remember?
Wait, is it 10 to the power 4 times 2?
You remember that? Is that the answer?
Yeah.
Oh, yeah. So this is 10 to the power 4 times 2. Okay. So here is the third formula with exponents. X to the power A to the power B equals x to the power A into B. Now, if you want to know why, we can solve it also. All the formulas that we have seen so far, we can solve it also. Okay? So there are three things that we have primarily learned as part of exponents. And I have given the sums to Arna. Did you get a chance to do the homework? A little bit? Okay. Have you brought it? No. Okay. So from the next class onwards, what I request you guys is, the homework that I sent to you, just do it on a piece of paper. It's only 2 of you, right? So you can bring it here. I'll check just to make sure that, okay, whatever I've explained, you guys have understood the right way. You're doing the calculation right way. And if there's something to be corrected, we'll do the correction. Okay? Yeah? Let's say when the number of students in the class increases, let's say becomes 10, and I don't get enough time to check for everybody, then we'll change our approach. What I do for the larger groups is, I give the homework to kids, I ask them to do it and show it to their parents, saying, okay, this is what I learned, this is what I did. So that way, when you explain to somebody, it's okay. When you explain to somebody, you'll be confident that yes, I have learned. Your parents will also be confident that yes, my kid has learned something new. And then when the way you explain, it enforces that whatever you learned, you have mastered it. Okay? And get a signature from your dad or mom, whoever is checking this one, and bring it so that I don't have to spend time, kind of checking the homework for a larger group. Now, we come to geometry. Are you okay to come to geometry?
Yeah.
Okay.
Yeah, I'm fine.
Okay. What is the difference between these two? What are these two?
They're parallel lines.
Okay, that is one example. What is the difference between these two?
Oh,
Arrows.
no, wait. I know. One of them is a line and the other one's a line segment.
Okay. Yeah, you were saying something. Yeah, same thing. So the one with arrow is a line. It can extend as far as long you want. This is a line segment. It has a fixed length. Okay? So line, when you talk about a line, it doesn't have a fixed length. It's like a direction. It says one way this, one way this. Go as far as you want. Okay? Line segment is saying, okay, these are 2 points connected, and this is the length of this guy. Okay? Now, this is first part. Now there's one more flavor to it.
That's a ray.
That's a ray. So the ray is this. Okay. Now, why did I take my phone out? To show you guys this. Okay. So Arna and Mitran here. What do you see here? Something starting from here, going far, right? If it's not reflecting, It's like the
Extending forever in one direction.
in one direction actually. So it's like this. So here is the source of the light, and it's traveling as far as it can. Since we had a wall here, it had to stop here.
I have a question.
Yeah.
What's the normal, like the normal line called?
Huh?
Like the normal one?
Just a line.
And then the one with the arrows?
So
Both
okay,
the
so
arrows?
so when you say line, you simply mean it has arrows. When you don't have arrows, it's called line segment.
Thanks.
Line segment, a portion of a line. Okay. And third flavor of that was called a ray. Okay. Ray is something like, always remember a torch or a phone light. So when you turn on your light, it starts from here. So there is an origin point. Okay. So you don't have an arrow here. It's just a starting point, and then you have an arrow in the other direction. It can go as far as the space permits. Since my board is ending here, it will go up to here. But if the board was bigger, it could have gone further also. Yeah. This is called a ray. This is the first thing in geometry. Now comes this. Look at this together. What is this?
These are parallel lines.
Parallel lines. Yeah. What is the property of a parallel line? Why do we call them parallel?
Because they're same. Or like,
No, but it's because they're like going straight at the same distance but never meet.
So always relate a parallel line with a railway track. It is never supposed to meet. The day it meets, there will be a train accident. Yeah? Yeah? So parallel line is nothing but a pair of lines
That never meet.
they never meet regardless of how far you extend them. Okay? And the distance between them remains fixed. Because if the distance starts decreasing, meaning they are coming closer and they'll meet somewhere, the train accident happens. Parallel line doesn't allow train accidents. Okay? Yeah? So this is the other thing that is called parallel line. Some properties of a parallel line. If you draw two parallel lines, okay, I mean basically a pair of parallel lines, and the third line cuts this guy. Let me name these angles. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. Okay, these are the name of the angles. Okay. Do you know what is the relationship between angle 1 and angle 3?
They are vertical angles.
Okay, vertically opposite angles. Are they same or different?
They're same,
They are same.
but they're like opposite.
Opposite, yeah. It's like a mirror image. Yeah. So here, I made it look very dirty. Let me clean it up. So when I have parallel lines, okay, this angle and this angle will be same. Okay. So always look at this. This angle will be same. So this angle will be same. This angle and the angle opposite to this, that also will be same. This has nothing to do with parallel lines actually. It's like two lines crossing each other. Okay, this angle same, this angle same. Okay, but the interesting fact comes around parallel line is this. This angle and this angle will be same. Okay, that is what we are learning as part of a
Yeah, I think I know. They're called corresponding.
corresponding angles. Yeah. So this angle will be same. 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 These are called corresponding angles, meaning angles on one side of the parallel line. Yeah? Okay? So this is one property I would want you guys to kind of get used to. Now, if I have a straight line and I draw a line like this, how many angles I'm making here?
That's called out. You're making two angles which add up to 180 degrees.
Okay.
And they're called supplementary angles.
Yes. So I will make sure that everybody in the class gets a chance to talk. Okay. So I'll point at you guys, and when your turn comes, then speak up. So that way, I can pay attention to all the students. Okay. Good that we have only 2 students right now, but tomorrow if I have 4, I have to make sure everybody is learning. So now, question to Arna: if I have one line, I have drawn another line here. So this guy cuts this line here, this point. How many angles I'm making?
4.
Okay, that's one answer. Okay, let me hear from Bitran. How many angles I'm making?
You're making 2.
2. I don't agree with both of you.
Hmm?
We are making 3 angles actually. If you look at this point, this is one angle,
Yeah.
this is another angle.
Oh.
Yeah, I mean, again, it's just a way of looking at it. Okay.
Okay.
What you said was not wrong. You were also very close, but I'm just giving you another perspective. Okay. So look at this as a point. This is one angle. This is another angle. This is third angle.
Mm-hmm.
Now, this is not what I'm trying to teach. I'm trying to teach something else. So if I have a line and another line cuts this at this point, the total angle that I make from here to here, Arna, how much is that?
180.
180. You agree? You agree?
Yeah.
Yeah. Okay. So that is another property that you will kind of be able to relate to when you look at parallel lines now. Okay. So this angle plus this angle is 180 degree. Okay. Now let's look at a parallel line quickly and see if this property is of any help. Okay. We learned that corresponding angles are same. So this angle and this angles are, these two are same. Yeah. Okay. Now I'm trying to say that, forget about this part. I'm saying that as part of parallel line, this angle and this angle are also same.
Part of parallel lines is angle and that angle. Yeah, they are same, but it's like upside down.
Upside down.
Mhm.
So now
I think I know what's this called. I think it's like, I kind of forgot what was the name. Was it like alternate interior angles?
alternate interior angles. Okay. Now name, you guys will know. Okay. I'll tell you how it is possible. Okay. Let me explain that to you. Yeah.
Mm-hmm.
So what I'm saying is this angle and this angle are same. This angle and this angle are also same. They are called alternate interior angles, meaning on opposite side of that third intersecting line, they are same. Now let's prove one. Okay, why it is same. So these are your parallel lines. I'm saying this angle and this angle are same. Yeah? Arna? I'm trying to prove this angle and this angle are same. Okay? Now let's see how we'll prove it. Now we know this angle and this angle are same. This and this are same. Parallel lines. And this angle and this angle are same because they are opposite line.
Yeah.
Opposite angles. So that means this and this are same. Very simple to prove. This is another way of proving it. Okay. This angle and this angle together is 180 degree.
Yeah, it's also called linear pair.
Yeah. Okay. Name part I would let you guys figure out because you deal with it every day. I'm just telling you the mathematical side of it. How do you prove it, right? This angle and this angle together is 180 degree. Okay. This angle and this angle is also 180 degree because this is one line, right? This angle is 180 degree. We know that this angle and this angle are same. That means you can relate. So let's say if you say A to this one, this is also A, and we are trying to prove, okay, this, okay, fine. Let's not go this way. Okay, so we know this and this is 180 degree. This and this are same. You don't need this 180 degree thing. Okay, you can simply prove it by this and this angle being same, and this angle being same. So this and this are same. It's like A equals to B, B equals to C. So A equals C. That's what we're doing here. Yeah, with me?
Yeah.
Confusing? Little bit. No, I mean, just be honest. It's okay. I mean, if I'm making confusing, if I'm making something confusing, I'll clarify it. Okay. Anna, you're okay?
Yeah.
Okay. So just to do a recap, if you're talking about any parallel line, a pair of parallel lines, and the third line intersects them, this angle and this angle will be same. Okay?
Okay.
That's my order. So this angle and this angle will be same. This angle and this angle will also be the same. So this is called corresponding angles. So imagine this, there are two lines. This is above this line and this is also above this line on the same side of this third line. Corresponding angles are same and the interior and internal angles are also the same. Yeah? Okay, so this is second property. Third thing, obviously parallel lines never meet. The distance between the parallel lines remains the same. They don't change. This is only about the parallel lines for now. Now, let's look at few more shapes. Triangle. What are the flavors of triangles you guys know?
3.
Okay. Yeah, I mean, be loud and clear. It's okay. If something is wrong, I'll correct it. It's fine. So, what are different types of triangles you know?
Triangle.
Triangle is triangle. Okay. Any flavor that you recall? Have you heard of something called equilateral triangle?
Yeah.
Okay. How about you?
Yeah.
You have heard equilateral triangle? Is there any other flavor of triangle that you remember?
Isosceles triangle. Scalene triangle.
Acute.
Acute angle triangle. Okay. Yeah. Obtuse angle triangle also. Okay. So now, before we go that far, let's quickly look at the basic properties of a triangle. Triangle is a polygon with three sides. One side, two sides, three sides. And three angles also. So this is the minimum, the basic property of a triangle, any triangle. Okay. So it will have three sides and three angles. Okay. Clear? Now, you can do classification of triangles based on two things. One is depending on the sides and second is on the angles. So since the way we recognize triangle is by sides or the angles, right? It has three sides and three angles. Now let's look at sides. So there are three sides, right? If all the three sides are same, meaning if this is 4 centimeter, this is 4 centimeter, this is 4 centimeter, meaning all the three sides are same length, that is where you say equilateral triangle. Okay. If only two sides are same, what do you call them?
Acute angle.
No, only two sides are same. Isosceles. Yeah. So if the triangle is like this, where this is 3 centimeter, 3 centimeter, 3 centimeter, it is equilateral. If there is a triangle like this, where this side and this side are same length, this is different. This is called isosceles triangle. Okay. Okay. And what was the third one? Scalene.
Yeah.
That is when everything is different.
That scaling is when different sides are not equal.
Yeah. None of the sides
Both
are equal.
sides are not.
All the sides are not equal. Yeah. So basically, it's something that is not equilateral or isosceles is scalene. Done. This is based on this is how you're classifying the triangles based on the length of the sides. Now, if you look at angles. There are 3 angles. Based on the angles, also you can classify them. Okay. Let's look at the angles first. If the angle is 90 degree, I'm not looking at a triangle right now, I'm just looking at angles, okay? If the angle is 90 degree, this is called a right angle triangle. Right angle, this is right angle. If it is greater than 90 degree, meaning angle like this, obtuse, yeah? If the angle is less than 90 degree, acute, I like this name, acute, something which is cute, meaning small,
Acute angle.
acute angle, yeah? Angle which is cute, meaning small, smaller than 90. 90 is your reference frame. Okay, so that's how you can remember this. Okay, now, so you know the definition of acute, obtuse, and right angles, right? Now, simple, you can relate it. If there is a triangle with one angle less 90 degree, meaning there is an angle which is a right angle, this is called right angle triangle. Angle triangle. Okay. If all the angles are less than 90 degree, meaning there is a triangle where all the angles are less than 90, okay, all are less than 90 degrees. It's an acute angle triangle. All the angles are acute, so that is an acute angle triangle or acute triangle. What if the angle is 90 degree? Right angle triangle. One of the angle is greater than 90 degree. Obtuse angle triangle. Clear? So we know what is right angle, we know what is obtuse angle, we know what is an obtuse angle. Now, how do we relate that property with the property of a triangle? If one of the angle is more than 90 degree, one of the angle is more than 90 degree, that is, it has an obtuse angle. So the triangle is called obtuse angle triangle. If all the angles are below 90 degree,
Acute.
it's an acute angle triangle. One of the angle is 90 degree, is right angle triangle. Now, a very stupid question to you both. Can I have a triangle with 2 angles 90 degree?
Have a triangle with 2 angles
90 degree.
No.
Yes. No?
Yeah.
Yes? Okay, he's saying yes. How about you? Yeah? I'll prove both of you wrong. I'll tell you why. Do you know what is the total? What is this? Okay, I'll teach you guys an interesting formula today. If you're looking at a triangle, this is one angle, this is one angle, this is one angle. If I sum all the angles, what is the total value of all the angles?
180?
180. So, after today, if somebody says, what is the total value of the sum of all the angles in a triangle? It has to be loud and clear, 180 degree. It will never ever change. This is like a universal truth. Okay? So, sum of all the angles of a triangle is 180 degrees. Now, I was asking, can I have a triangle which has 2 of the angles as 90 degrees?
No,
No.
that can't be possible.
That can't be possible. Because if you say 90 degree is always like this. This is 90 degree, perpendicular.
If 2 angles were 90 degree, it would be like a rectangle or square.
No, so it will not be a rectangle or square. It will be a undefined shape. You have 3 sides, and these 2 sides are not going to meet because these are actually parallel now. Yeah? So you can never have a triangle with 2 angles 90 degree. Another way to look at it is 2 angles 90 degree means total of all the angles cannot be more than 180. I've already consumed 180 here by having 2 angles 90 degree. Means the third angle is 0 degree. Means that line is not meeting. 0 degree is what? 0 degree means like this. Yeah. So imagine a triangle. Okay. This is one side. If this is 0 degree, this is 90 degree. This is 90 degree. This is 90 degree. Third angle is 0 degree, meaning these two lines are touching each other at 0 degree, meaning they'll make a line. So if you try drawing a triangle with third angle 0 degree, this is what you'll get. Does it look like a triangle by any means?
No,
No?
it looks like a split half destroyed rectangle.
Yeah. So that's why I was asking. So see, these are relatable questions. Okay. If you know. Okay. So let me teach you guys one interesting formula today. You might want to note it down.
Wait.
2 into n minus 4 inside the bracket multiplied by 90 degrees.
Okay.
Angle of a polygon. Okay. This formula is total angle of a polygon. 2 into n minus 4 into 90 degrees. Now, polygon means anything which has more than two sides. So, triangle is a polygon. Here, n is the number of sides. Okay. So, I'm trying to find out what is the total angle inside a triangle. So, I'll put that formula here. 2 into n. And here in a triangle, I have three sides. I'll put 3 minus 4 into 90 degrees equals 2 into 3 is 6 minus 4 is 2 into 90 degrees equals 180 degree. So I was saying sum of all the angles in a triangle is 180 degree. This is my mathematical justification for that. Okay. Now let's look at something interesting. A rectangle or quadrilateral, four sides. Be it a rectangle, be it a square, be it a trapezium. We'll learn about all these later. Okay. Be it a rhombus, be it a kite. Okay. Sum of all the angles. How much is the sum of all the angles for this one? We'll use the same formula. 2n my sum of all the angles of a polygon. 2n minus 4 into 90 degrees. Here n is the number of sides, so 2 into n. Here we talk about a quadrilateral, be it a square, be it a rectangle, trapezium, rhombus, rectangle. 2 into 4 minus 4 into 90 degrees. 2 into 4 is 8 minus 4 into 90 degrees equals 4.
360.
Yeah. So you will never ever have a quadrilateral, be it a square, be it a rectangle, be it a trapezium, be it a kite, be it a rhombus, whatever it is. Sum of all the angles will never ever be more than 360 or less than 360. So tomorrow if somebody comes to you saying that I have a shape which has 20 sides, okay, 20 sides, he might have built something like this. He is asking you to find out the sum of all the angles. You'll just apply this formula. You'll say 20 sides, okay? So 2 into n is 20 minus 4 into 90. This is my answer. So 40 minus 4, 16 into 90. This many degrees? 6, 9 ja, 144. 1440 degrees. And you can use that for pentagon, hexagon, whatever. Just apply n to the number of sides, and this will tell you what the total angle would be. And that will never ever change. That cannot change. Okay. So that kind of brings us to the end of today's class. But before we disperse, remember this. This is a trapezium. This is a rectangle. This is a square. We'll talk about other shapes and properties and area, perimeter, everything in the subsequent classes. This will take 3-4 classes, okay? This is a very interesting concept. But when we look at these quadrilaterals, all have four sides, all have four angles, and sum of all the angles will be 360 degrees, no matter what. Okay? Here, all angles are 90 degree in a rectangle. In a square, all are 90 degree. We'll talk about the property of these shapes in the subsequent class. Here, they are not. This is more than 90, this is more than 90, this is less than 90. But all put together cannot go beyond this. This is a universal truth. Okay? And how? That is what we derived. So, what all did we learn today?
We learned about geometry. We learned about.
Okay, one by one. So you will say one thing, she will say one thing. I want to make sure that both are with me, okay?
We learned about the type of triangles.
Okay.
We learned about the angle formula 2 into n minus 4 into 90 degrees.
That helps you find out that sum of all the angles
Those are-
inside a polygon, regardless of how many sides you have. Okay.
Learned the equations for them.
Equation. We did a revision also of the exponents, and we also learned some of the properties of the parallel lines. Okay, and we also learned.
We also learned about line segment, ray.
And then Arna, what else did we learn? We learned about properties of triangles.
Yeah.
So we can classify triangles based on the sides or the angles.